This is a presentation on the measures of dispersion. Take a look at the three different dartboards labeled A, B, and C. Can you tell what the main difference is between them? At first glance, picture A has the darts scattered all over the board. In picture B, the darts are still scattered but seem to be closer together towards the center of the board. In picture C, all of the darts are either directly on the bullseye or right near it. These pictures illustrate the concept of dispersion, which is very important in statistics. Dispersion, or scatter, involves how spread out the individual data values are from the mean of the given set of data. Since the data in picture A are very spread out, the set of data is expected to have a high dispersion. In picture C, the set of data is expected to have little dispersion because the individual data values are bunched up towards the bullseye. There are two measures of dispersion, range and standard deviation. The range of a given set of data is a statistic that gives an indication of how spread out the data is. The range for a given set of data is found by subtracting the least value L from the greatest value G in a given data set. In reports, the range is often reported by stating the smallest and largest scores. For example, the scores ranged from 3 to 9. John and Joe took 5 quizzes and wanted to determine the range for their scores. John's quiz grades were 89, 85, 99, 94, and 90, and Joe's quiz grades were 75, 85, 78, 90, and 91. To find the range, the numbers have to be placed in sequential order. The range for John's quizzes is calculated by subtracting 99 minus 85. The range for this set of data is 14. For Joe's scores, 91 minus 75 equals 16. The range for Joe's scores is 16. Between the ranges, there is less dispersion for the scores on Joe's quizzes. Although the range is easily computed, it is not considered to be the best measure of dispersion since it only involves two extreme values. There is no indication of what else is going on with the rest of the data. The measure of dispersion that considers all scores in a given data set is the standard deviation. The standard deviation for a set of data that represents a population is denoted by sigma. The standard deviation measures how dispersed the data are about the mean. The larger the standard deviation, the more dispersion. The lower the standard deviation, the less dispersion. The data can also have moderate dispersion depending on the data set to which it is being compared to. There are 5 very important steps to calculate the standard deviation. It is imperative to follow these steps exactly in order to have accurate answers. Number 1. Find the mean for the given set of data. Number 2. Find the deviation from the mean for each value in the data set. Number 3. Square each deviation. Number 4. Find the mean of the squared deviations. This is also referred to as the variance. Number 5. Find the principal square root of the mean found from step 4. Find the standard deviation for the following set of data: 6, 8, 11, 14, and 16. Use the 5 steps described previously to calculate the answer accurately. First, find the means for the given set of data. Reminder, to find the mean, add the values together and divide the sum by the number of values. So, 6 plus 8 plus 11 plus 14 plus 16 equals 55. 55 divided by 5 equals 11. 11 is the mean. Next, find the deviation from the mean for each value in the data set. The deviation of the mean is found by subtracting the mean from each individual value in the data set. The results are as follows. When adding the deviations from the mean, the result should be 0. Getting 0 for an answer does not necessarily mean the values are correct, but it is a good checking point for this process. Next, square each deviation individually. The results are as follows. Then, find the mean of the squared deviations, which is also known as the variance. Add all of the squared deviations and divide the sum by the number of deviations, which is 5. Divide 68 by 5. Therefore, the variance is 13.6. For the final step, find the square root of the mean calculated in step 4. Therefore, the square root of 13.6 equals 3.69.